All right, welcome everyone. This is Trends in AI for March 2023, streaming live from Lab 42.
From a snowy Lab 42, if I may say. Outside, the snow is whirling around like last week when I was skiing.
And we'll just wait a couple of minutes for people online to join. We're going to talk about all the developments from this past year and all the news and all the rumors. So anything before we start?
Let's dive into it. My name is Jakub Zavrel, and we're bringing you this monthly review from Zeta Alpha, Trends in AI. So at Zeta Alpha, we have two goals. One, to inform you about the latest trends and developments in the field of AI, and two, to build the best platform for connecting people and knowledge. And in this show, those two are actually connected because we're using our own platform to discover what's trending, and we'll be talking about that a bit more.
And my name is Sergi. I'm an analyst at Zeta Alpha. I try to make sense of what's happening in the AI world, and I collect these monthly recaps of research and interesting news. Shall we dive into it?
So let's dive into it. News. What's been happening?
The first topic that we've been highlighting for a couple of months is the status of Google and Microsoft.
How much percent do we want to talk about GPT today? Well,
I promise I tried to keep it to a lower.
You muted it a little bit.
Yeah, for
Good.
sure. But
it's hard, right?
Yeah, this is still very much on the minds of Google executives, right? As it seems.
Yeah. So since early February, basically everybody has announced integration of GPT into their products. We have launched it very early February with Zeta Alpha. So now I think Microsoft actually delivered. I think GPT is integrated in Teams, in Bing.
Correct.
Slack has announced, Salesforce has announced.
Some integrations, but I don't think it's completely widespread.
HubSpot has, there's a really nice kind of demo video from the CTO of HubSpot called ChatBot online. It's amazing, you should watch it. Fully integrated, it's not released yet. And Google, this is Bloomberg reporting. Google's plan to catch ChatGPT, well, they have some catching up to do, obviously, is to stuff AI into everything. Is that a good recipe?
I don't know.
It looks very similar to what other people are doing.
To me, my sense is we might just talk a little bit about it. It's like Google has probably like the largest scale research efforts in AI. Yet it does feel like it's sometimes a bit scattered and all over the place, and it's not so clear how it translates to their products, and like their kind of research and products are very much far apart.
I think this is exactly what they should not be doing. I mean, AI is already all over Google products, right? In your Gmail, in YouTube, in the main search. And the one thing that they should do is launch a service where they make large language models that they have, obviously, in the lab, available to customers for a fee. That would like turn the game around, but they're not doing that. Yeah,
so far they're not doing that. So we'll see.
And how are they going to do that? Well, not with the help of Jason Wei.
Jason Wei is one of the high-profile researchers, right, at Google, producing a lot of the research.
High-profile. He is a guy who just graduated from university 3-4 years ago.
But
I think he's 25, right?
Yeah, but he's producing like...
he was on all the major papers.
Yeah, all the major papers on large language models from Google.
So, I like this stab in this tweet where he said, "I can't wait to see the impact of AI on society." Ooh. But his brother is still at Google, Jerry Wei. So, and lots of other talented people, of course. Last month we got picked up, our data got picked up by The Economist, who reported on our measurements of the productivity in terms of volume of all the large research labs. Google clearly on top, Microsoft second, OpenAI at the very bottom in terms of volume. And it caused quite a stir because there was online, like Jan LeCun weighed in, like, we go for quality, and OpenAI is not really producing a lot of new stuff. And besides, volume is not the same as impact.
Yeah.
we picked up the glove, right? And we did this analysis of impact. Well, how do you measure impact of what happened last year? So basically, we looked at citations. It's kind of like citations have a bit of a lag, and it takes some time for papers to get cited, but already from last year, you can see quite some volume. And we compiled the top 100 most cited AI papers for last year, and 21 and 20. So it's on our blog. Must read the 100 most cited AI papers in 2022. And indeed, if you look at some of the graphs in that blog, this is the ranking by total number of citations in those 3 years. You do see that Meta actually moves up quite a number of spots. So they
exactly. If you look at the how much they convert, like Google is still in the lead, but it's not by such a large margin.
We'll get to it. This is just the number of spots in the top 100.
Exactly.
The number of research papers that have an affiliation at Google or Meta or Microsoft. We got a lot of questions about this. It was a very popular thread on Twitter and made Hacker News front page and all that. And obviously, it looks like big tech is very dominant.
Yeah, exactly.
But actually, if you look more closely, kind of in the long tail, there's a lot of universities, right? And if you look at this top 100 in terms of authors, and you look at the graph right there, you see that academia is actually pretty well represented. It's about half-half. Yeah,
exactly. Just like you mentioned, the academia has a much longer tail of smaller institutions that get in the top 100, whereas, these large
and there's nowadays some of these organizations were neither industry or academia.
Like collectives or
Exactly. So we also rank them by country.
That's very interesting,
based on the affiliation, obviously, not some kind of passport check or how does your name sound, but some pretty nice, it's kind of the usual suspects in the top 3,
I guess
right?
One of the things that I would like to highlight here is that whereas when you look at the publication counts, the raw publication counts, China is quickly catching up with the US. It does seem like when it comes to high impact research, the US still has a larger
very significant lead.
Right?
Yeah. And UK number 3, but what's the surprising thing there?
The surprising thing is that most of the UK, I think it's like 60-70% is DeepMind.
Yeah, which is
so
kind of Google, right?
Kind of Google, but it's like lines are very blurred. So.
So a couple of nice, very high rankers here. Singapore, top 5. Australia. Then some of the usual spec, and we're of course very proud with Netherlands top 11. Okay, but I mean it's a big impact for such a small country. It's Singapore is a smaller country. Okay, fair enough. And actually some of these people are in this building here, like Max Welling.
Exactly.
So congrats with that.
Yeah, and finally when you group European countries together, they get a pretty similar to Asia contribution to the top 100, and then North America is still like much farther ahead.
So if we team up with China, we're almost ahead, right? Okay. Let's look at that in a slightly different way. So obviously, if you look at organizations like Google, they're super large research teams, right? But how many of their thousands of papers actually made it into the top 100 of citations?
It's actually very, very few.
They're here.
Yeah,
top 10. Top 10. That's pretty good. But Meta a lot higher. But obviously the crown in impact goes to
OpenAI.
OpenAI.
It's quite insane when you look at it. I mean, they have been publishing the order of dozens of papers a year.
And half of their papers make it into the top 100 most cited. So I think the criticism in terms of you're not producing anything impactful.
That doesn't.
Pretty empty. So the full list of the top 20 is here, and you can read the hundreds of papers. Check whether your paper is there on our blog. All right. So that was a nice exercise for last year. What's going on right now?
I would say like March has been a lot of multimodal stuff has been coming up. There's even some rumors that we're gonna talk about shortly about GPT-4 being multimodal. So yeah, there's been this explosion of hooking up language
where
models.
January was kind of the month of music AI. Really, February and early March is all about multimodal. So we have Blip 2 from Salesforce. We have Cosmos 1 from Microsoft. We have Prismer from NVIDIA. We have PaLM-E just this week from Google. We're going to talk a lot more about that.
Yeah.
And Visual ChatGPT that came out yesterday. So, and a lot of other stuff, data sets, and robotics, and very much embodied and multimodal ones. The rumor mill.
Yeah, this is a pretty recent. I think this was news from yesterday or last night.
Is it news? I don't know.
I don't know. Apparently, the CEO of Microsoft Germany kind of mentioned GPT-4 and its capabilities and the fact that it would be released next week in some quote, kind of like informal.
We will have GPT-4 next week. It's
and it doesn't seem like they retracted anything from what they said as a mistake or something. So it does sound like something up is coming up. What I'm a bit confused about is something from Microsoft, right? And the GPT series of models is very strongly associated to OpenAI. So I don't know if they're gonna make some kind of joint announcement or just like
even bigger announcements.
Over.
Who knows?
I don't know. We'll see. And I'm also very surprised about the multimodal nature of this model. I thought that the GPT
doesn't surprise me at all. I think makes a lot of sense.
I thought that the kind of like foundation of the GPT series was very strongly on text, and if they started going on multimodal, they would kind of like.
Once you're in transformer land, anything is text.
Yeah.
Right. Tokens.
Yeah, but it's still kind of like more unclear how you interact with an API that also has images and other modalities.
Alpha, the one strong European producer of large language models as a service, already was multimodal with their Luminous model, right? So it's not that far-fetched. I think it makes sense.
Well, we'll see. Yeah.
I just don't entirely believe this rumor, but I'll bet you a bar of chocolate that it's not true. I think if I were Microsoft, I would not let the CTO of Microsoft Germany announce such a major thing.
Yeah. But I mean, it doesn't seem like he announced it. He just kind of like mentioned it in passing. Kind of like some.
He should be fired. I don't know. All right. So what's real news? Well, one of the big news items really has been. The release of the ChatGPT API, right?
The GPT 3.5 Turbo.
Yeah. Have you played with it already?
Yeah. It's, I mean, it just pretty much as you would expect. I mean, it doesn't surprise. It just, most people have interacted with
the most surprising thing was the price. It's 10 times cheaper than the actual previous generation of GPT.
And what is...
It's kind of the same quality, right?
It's, I mean, not quite the same quality when it comes to following very complex instructions, right? But when it comes to conversational and like less complex instruction, it does seem like it's very comparable. What I do find quite a bit annoying is that they haven't provided many more details about what is behind this. Like, is it like they had some very clever optimization on how they run it, or just like some distillation? Is it like what kind of like how many parameters does it have? Like some of these, I feel like.
I'm especially like fascinated by this price point because at the previous price point it was kind of 2 cents per kind of 100 per 1,000 tokens. That's not very expensive, but you want to avoid doing like lots of calls, right? Yeah. And with this price point, you're like, let's do another call just to try it again, and it's
it certainly hits
really,
a very different spot.
It really hits kind of very different qualitative possibilities. But I think it's actually price dumping. I don't know. I saw some.
You think that they're just not making a lot of money with?
I saw some calculations that it's kind of you can just about do that price, but. The register says this has to be a loss leader to lock out competitors. It makes a lot of sense, right? What are Cohere and Anthropic going to do? They have to follow.
Yeah. No, absolutely.
Talking about Anthropic, this kind of Claude is, the Claude chatbot is kind of available, right?
Yeah, it's kind of available. It's not publicly announced or anything, but we have a slide on that. There's some apps and startups that kind of started having access to it. There's integration with Slack, so we got to play around with it, and it's kind of like slowly kind of making it
you can
public.
test it, basically.
Yeah, exactly.
So other news, let's just run through it quickly. Source AG is a Dutch AI agriculture firm, raised a lot of capital, 23 million, for kind of optimizing sensor and actor networks in greenhouses. Eleuther is now an official organization, sponsored by Hugging Face and Stability, I think. A few other sponsors. And what else? Hugging Face, of course, teamed up with Amazon.
AWS.
Right? I don't know.
Well,
did they really team up? Or
I just saw the headlines, like the news piece well, at least what I read didn't cover too much in depth what their agreement was about exactly. But it does seem like they joined forces somehow for some of the compute infrastructure.
Yeah. I don't think it involves like stock or equity,
no,
like with OpenAI
so.
and Microsoft. It's just some kind of business deal.
Yeah, exactly. And finally, Spotify's new interface is gonna use a lot more AI and recommendation heavy.
What I read is that they're gonna talk between the songs. It's like your Discovery Weekly, and then there's gonna be this synthetic DJ who talks about the songs.
There's this new DJ feature that I still have not been able to test myself. That is pretty much that. Like they have like a kind of someone who's.
I want to pay extra to avoid having that DJ basically. And it's gonna have advertisements probably.
Yeah, I don't know. We'll see how that evolves, but.
I'm a big fan of Spotify, but this is borderline. All right, so let's talk about Claude.
Like we mentioned, I mean, we've been in the last couple of months mentioning how there was a bit of a danger of OpenAI really eating the whole space of language models, and not a lot of these open source initiatives like being really quite up to the quality of ChatGPT.
Just offering decent product,
we got to try the Claude language model from Anthropic, which is this startup, right? That started with a lot of people from OpenAI. Google invested heavily in it a month ago or something. More or less.
Dario and Daniela Amadei.
And I have to say it's been like very surprisingly good and like better than ChatGPT in many ways. And also worse than ChatGPT.
And this is trained using this constitutional AI approach, right? Where basically AI is given a set of principles and then kind of self-criticizes its own output and then retrains using this.
Exactly. So this is kind of a slightly different approach to the problem of alignment in language models, and I feel it's very interesting. One of the kind of the main difference between ChatGPT and Claude that has been kind of observed qualitatively is that Claude is a little bit harder to prompt inject or like to jailbreak it into kind of some out of character language model. Yeah. And it might be that there's some of these training schema that they have used is different. I have to say that personally it's been very interesting because I feel like ChatGPT is a little bit more of a like PR friendly, safe sort of personality to it, and Claude is a little bit more opinionated, but it's also opinionated on when like it doesn't want to do something. For instance, I tried to make it kind of write a simple Python function, and ChatGPT is very happy to do that. But Claude is very stubborn in like, no, I'm not. I don't want to do this. This is not useful for you. I know what is good for you, kind of a vibe. Right. Like I say, no, but I actually want your help in this. Can you just try? And they're like, no. I know what is.
Did you try all these? Like I'm a character in a novel, and I'm trying to.
I'm positive that like I'm sure that you can like eventually make it do something like that. But the kind of like general sense of it was a bit kind of more stubborn and less a little bit more raw. But it was in a lot of tasks, like in creative tasks, and in a lot of ways, it was even better than ChatGPT. So I think that's very interesting because you can see like how they're just like, in some ways they're just different. They're just like, you can't pinpoint if it's better or worse because it's kind of like a very subjective type of evaluation. But it's super interesting. Like these
Any
models.
date out there yet when it will be released to the
No,
general public?
not that I know of. No.
Right. Well,
but you can totally try. This is on an app called PoE, like PoE.
Yeah.
It's an app by Quora where you can just try different language models, and it's a very useful thing to try out.
One step closer to having good competition.
Yeah, exactly, which is very good.
And Google, you need to release your large language models as a service on the cloud platform.
Maybe someone will start using it then. Okay, yeah. So the Waluigi Effect, I wanted to include this. This has been sort of a discussion going on Twitter There hasn't been, I think, any like paper on this, but it's been a bit of a meme discussion. Okay, so for people who are not familiar with this, the Waluigi effect has been this sort of observed phenomenon.
It's an official thing, the Waluigi. It's like you can find it in the Oxford Dictionary.
Yeah. So is this sort of strange phenomenon that people observed, especially in Bing from Microsoft, in which whenever a language model is sort of aligned to be a certain character, you're kind of implicitly making it more likely that it suddenly becomes the antithesis of that character, right? And this kind
Dr.
of
Jekyll and Mr. Hyde.
Yeah, and this is kind of like how it relates to Luigi and Waluigi, the characters from Nintendo. Like Waluigi is kind of like the antithesis, is like the kind of like the
bad guy,
the bad version of Luigi.
Yeah.
And they have very interesting sort of reflections on. I think that the most interesting thing about this whole discourse is that it's sort of like opening a new paradigm for thinking and discussing language models that kind of like ties together ideas from statistics and ideas from like psychology because in a lot of ways you need sort of psychological vocabulary to talk about these language models and make sense of them because the sort of
close your eyes and try not to think of an elephant.
Yeah, exactly. But it's like I don't know. I feel like a lot of the vocabulary that we have, it's just like not enough to talk about these language models right now. And this has a very interesting sort of way of talking about it, and like and sort of thinking about personalities and how alignment is very hard in this sense. And like the main argument is like whenever you tell a language model that's kind of like trained on the whole like large broad data out there, whenever you sort of align that to be in a certain space of personality, which is like just a subset of the whole data that is out there for training, you're implicitly making it very easy to sort of like byte flip that information into something that's very different. And I think that's a very compelling argument that that is like very fundamentally hard to align these large language models.
Well, there's also a very simple technical thing that even since word2vec, if you have the embedding of white, it's very close to the embedding of black, right?
Exactly. And, so I feel like in the broad sense, like the argument for this effect is that precise one.
Yeah.
So we'll see. I feel like there might be more research coming up on this and like more serious discussion about it, which is going to be very interesting in the whole space of alignment.
Psychology department. Research group Waluigi. All right, so more about some other recent local news. We had this, and also about ethics of AI, obviously. So in The Hague 3 weeks ago, there was this conference, Responsible AI in the Military Domain. And we had this fascinating interview with Stuart Russel, one of the advocates for banning autonomous lethal weapons. Mm-hmm. You can watch it on our YouTube channel, and he argues that this is a really bad idea, and even the idea of responsible AI in the military domain is like a non-existent idea. Like he said, imagine having a conference about responsible biological weapons in the military domain. Yeah. But anyway, it's a great interview, and he argues that, well, first of all, there was this big announcement, and I think that's very relevant for kind of AI and harm, where the United States announced that AI systems will never have access to the nuclear launch code. They will never be involved in the nuclear sort of line of command. And then I joked, well, that sounds a lot more reassuring than not having lethal, kind of small, cheap drones. And he said, well, he has a very strong argument that cheap, autonomous, lethal drones are actually kind of on the same level of harm as nuclear weapons. Mm-hmm.
I guess like his main, but like, well, how I would paraphrase his main point is like if very powerful arms become very cheap, they might be available to players who don't play kind of rationally or like don't abide by the kind of like the sort of nation states type of rationales, and then you suddenly have terrorist groups that can like.
If you have 1 million drones costing $5 each,
exactly, and suddenly you can have a terrorist group
kill
causing
as many people as with a nuclear weapon.
Which is a bit scary.
So if you want to get involved in activism against that, check out the interview and some of the causes that Stuart Russel is promoting. What we are promoting is the Zeta Alpha platform. In case you didn't know us yet, it's a discovery and organization platform for knowledge in AI and data science and beyond, where you can organize your reading lists, your notes, and this all feeds into powering very good recommendations for you. And one shout out that we want to do is that we've recently integrated GPT, of course, who did join the bandwagon. No, we were one of the first, actually.
Yeah, we were on the first, yeah.
And this allows you to basically ask a question of any sort of search results. So you don't have to read the individual documents, but you get a nice summary with references, and it's kind of much more factual than the actual GPT results, right?
Yeah, so I was going to say, now I see a lot of news of companies stopping their sprint work to do like a ChatGPT sprint or like hackathon week, something like that. And we did that actually way back in December, right? So,
and now the news is that we're actually allowing companies to also do that on the internal data that you have, let's say in a Google Drive, in Slack, in Trello, in Confluence, and all those kind of internal tools. So, of course, each of them is going to embed GPT, but you want to have search across all of them and answers to your question from all of them. So this is a first sneak preview. And this is another feature of our platform, that we're able to take all the papers that come out in February, March, and basically map them using their neural network embeddings.
Exactly, and then automatically label them into semantically relevant titles.
With a little bit of help from
GPT-3.
From GPT, yeah. So this is this month's yield, right? So what's kind of special about this month?
Well, like we said, I think that multimodal language models has been one big.
Where are they?
I think the
language is not all you need. The actually language model, big red language model class is being taken over by multimodal.
Yeah, exactly.
PaLM-E language is not all you need. They're all there.
Yeah. Video to sequence.
Right. So how do you pick what you want?
Well, we do a mix of popularity on Twitter is a big one, relevancy of some authors that we follow, and just like my personal preferences as well, which
editorial.
I like certain things more than others.
Curator privilege.
Exactly.
Right. So number one.
The first one had to be there. Probably one of the most discussed.
Why did you pick this one?
It was all over the place, everywhere. So these set of pre-trained language models from Meta that they once again have released. Well, not fully released. They have released only with a license that allows you to do research, but in principle not.
I heard it's pretty
but I heard that there's some websites and some places out there where you can get the weights. Anyway, so this has been very popular. And I think it's very interesting to see that among all the big tech companies, Meta is probably the one who's always open sourcing most of their stuff. They still don't get that much credit for it, and they have this kind of very bad reputation.
How is this different than the OPT model?
Well, the OPT was trained to just be a replication study of GPT-3. So I feel like most of their decisions was let's copy what GPT-3 did, whereas here it's more like let's provide a foundation. And I think that one of the biggest differences, for instance, is that they follow a lot of more of the scaling laws from Chinchilla papers, and they choose to train a smaller model up to 65.
On a lot more data.
Yeah, exactly. For much longer when you compare it to PaLM, for instance, which is much bigger but less.
I think it's interesting that they don't benchmark OPT here in their own graph.
Yeah, I don't think that looks. OPT didn't perform that well.
No, it wasn't that good.
So you can, if you're a researcher, you can ask for the weights and start playing with this. I think it's super relevant for people to start translating.
Everybody's a researcher.
Yeah, but it's very important for people to start working building on top of these models, right? Because most researchers can't train these models, but they can run these on GPUs.
And I heard rumors that the code is not immediately usable, then you have to do a little bit of hacking to actually get it to work. But then you can get one pretty large model to run on a single GPU, basically.
Mm-hmm, yeah.
It's a 13 billion model, or yeah.
I think 13 billion on how many gigs of RAM? On 24 gigs of RAM, right? Yeah. So like people have started to applying all these quantization techniques and like int8 methods and.
So last month we were promoting a FLAN-T5 as the open source GPT alternative. So is that shifting?
One of the big differences is that FLAN-T5 was instruction tuned, right? And these models are not instruction tuned.
Not yet.
Yeah, not yet, or no one has still exactly. Which actually is very interesting because like this model performs really well on all these benchmarks, but if you try to use it, it's often not as easy to kind of tame, right? It's a bit like a wild horse, and like. This kind of goes to show how important this sort of extra step of instruction tuning and RLHF is in order to make these models very usable by humans.
But the scores on these benchmarks are pretty impressive.
Yeah. All right, so the second one is this paper called Consistency Models. I didn't see that much chatter about it, but it is a paper from OpenAI, quite interesting. It's a little bit of kind of a next step in diffusion models and generative image models. And they basically look at diffusion models and they say, okay, it's quite impressive that diffusion models can show very good generative capabilities, even being quite small. And they say that the reason for that is that they need a lot of steps to decode an image, right? You go from noise to image.
One less noise.
Yeah, exactly. But effectively, you kind of like have to do that steps many times. So like effectively, there's this kind of computational graph that is actually much larger than the network itself. Whereas for GANs and other generative models, you just need to do one inference pass. Yeah. And they basically sort of generalize this setting in which they learn a function, a neural network that goes from any arbitrary step within this whole diffusion process. So like it kind of like jumps, it kind of like jumps over these diffusion steps and then is able to generate from noise to data directly in one step without needing adversarial training, which is one of these things that GANs are a little bit sort of known for being very unstable. And like anytime you have some kind of adversarial loss, it becomes a little bit more fragile to train or harder. And they claim that they do this. Yeah. They showed it in relatively small images, so it's not like like DALL-E 2 level generation, but it's still a very promising sort of like next step in the diffusion sort of world.
Yeah, very cool, very interesting. By the way, I saw that just today a model was released called GigaGAN. It's a bit hard to pronounce.
I actually haven't seen that one. No?
GigaGAN is a very large GAN model. Okay. And seems to blow away diffusion models. So the battle is on.
Well, who released it?
I don't. I just saw it like 5 minutes before
we
started.
But we have to.
GigaGAN, check it out for next month's show. So moving from from image generation to multimodal language models.
To embodied language models, right?
Yeah, embodied. It's not just vision and language, but PaLM-E is vision, language, and robotics.
Actions. Yeah,
right?
exactly.
And actions.
And actions in the real world. Yeah. So I think that this is something that we've been kind of like highlighting or saying this is not some kind of surprising move by Google, but this kind of combination of language models and robots or like robotics has been a very fruitful one. And this, I don't know, I think one of the interesting things about PaLM-E is that it's massive, right? It's just, they just get their
It's the largest model kind of around, right? Yeah. So the main author of this paper, Danny Dries, is a student, PhD student, I think, at TU Berlin, and he went to Google to do an internship. There he found PaLM, which is 540 billion parameters.
Yeah,
and he found also just recently released Mostafa Deghani's 22 billion vision transformer, and he just smashed them together. And it worked so well that within this internship he produced this kind of groundbreaking paper. Well, congrats.
And I once again I feel like it's very interesting to sort of, because one of the big learnings from this kind of like scaling trend and like large language models has been that counterintuitively, maybe the larger a model you have pre-trained, the less data you need it to kind of like later adapt it to kind of fine-tune some tasks. And I think this is a great example of that. And perhaps more importantly, in this paper, they show this effect of positive transfer called, which is like this effect of when you train on all modalities, the performance on each one of those modalities goes up. And this is something that the paper from DeepMind, Gato, which also did something relatively similar, but on simulation,
to Gato,
was quite smaller. I think it was around 1 billion parameters. And they didn't show such a strong positive transfer.
It was a little bit hard for. They even had some negative.
Yeah, exactly.
Effects,
and
right?
some of them were negatives. And I think that this is very interesting because it's like it starts to show, like it hints at the fact that it might be also a feature of scale or like an emergent thing, that you need a certain size of networks in order to have very large degrees of positive emergence. So,
and how does it differ from, say, CAN? Because like SECAN, I think, is a language model which kind of generates language descriptions of actions for robots, right? But here they really kind of embed the robotics part.
I believe that the action state is still very much high level, and it's still.
But it's like a special kind of action tokens, like in Gato, right? I think.
I'm not sure to be honest. I think they might have some separator tokens, but I believe that the action description is still in natural language.
It's in natural language and then interpreted by.
For instance, you have an example here. Given embedding of the image, how Google grabs the blue box, and then the answer is first grabs the yellow block and place it on the table.
That's then translated by
exactly,
some
and then
other
translated
module.
to like some more like traditional motion control type of model. And
so interesting that this is a very like massive model, right? But you can do the same kind of model without the robotics part, okay?
Exactly.
But it has kind of visual language reasoning and question answering, all that.
So I wanted to highlight this one. There was also that one from Meta, but I think I quite like this one from NVIDIA because it takes a bit of a different approach, and it kind of goes back to this idea of expert models and sort of gets a lot of these vision models that are frozen and then kind of glues them
different
together.
Ones, right?
Like a depth estimation and I don't know, like object segmentation and like image classification and all of these things, and they use this information and kind of like combine it with some adapters, and they show that while their performance is not as impressive, the efficiency in training is much.
Yeah, it's actually a very small model, like I don't know, a couple 100 million.
I think that the trainable parameters are in the order of 300
million. Below a billion.
Below a billion, exactly. So that's certainly interesting.
I mean, this is how, like, as a talented amateur, you win Kaggle competitions, right?
Exactly.
Try a bunch of things, ensemble the hell out of them, and there you go.
Yeah, exactly. And what I was thinking is, with all of these PaLM-E models and like language model and robotics, I wonder. So a common criticism of language models is their lack of grounding, right? Or like this kind of like classical linguistic type
that's why you can add grounding pretty cheaply.
Exactly. Like what is sort of like the next natural criticism for this type of line of thinking?
Gary Marcus will always come up with something.
Yeah, I guess that's what I was going. I don't know. We'll see. I'm sure there would be something to criticize and say, well, these models don't understand anything.
And it's March Multimodal month, so we have another multimodal model.
Yeah, exactly.
Also came out like yesterday.
From Microsoft also.
From
so
Microsoft,
like they have a lot of
maybe this is GPT-4. Who knows?
Maybe they just like accidentally uploaded
the CTO
to
of Microsoft Germany saw this paper and he's like, we have it.
Yeah. So. I just
he might leave to start his own company on this model though.
They just use GPT to just like kind of like glue together a bunch of different things.
Yeah. What kind of did you catch? I didn't read it yet fully, but
no, me neither. I just like
what kind of vision models they use here?
My vague sense is that they just use pre-trained vision encoders, but
a bit like the NVIDIA paper.
Yeah, like a bit like just like from images get descriptions and then pass it on to ChatGPT, which is just kind of like this black box that gets input and then like chooses other models to like you give it a description. Like we have this, I think they have like 22 vision models, and they kind of have a description of what input, what output, and what capabilities each one does.
Yeah.
You kind of tell that to GPT, and then you pass it an image description, and then you ask ChatGPT, like, what model would you kind of use now?
This is a very classic AI architecture. So basically, you're using ChatGPT as a kind of blackboard or scratchpad, and then you're just like, letting it orchestrate which experts to call, and then the experts write their output back to the blackboard, and that's how you proceed.
And it's very closely related to the whole space of augmented language models, right?
Absolutely.
That we have a bit, and I mean, it's certainly very interesting spaces kind of develop. I mean, there's still a lot of problems with sort of robustness and like these sort of approaches tend to just break down if one of the steps kind of breaks and blah blah. But it's still very promising, I think. And
language is the universal interface, so it's very nice. Yeah. I'll be reading that more closely over the weekend.
This. I think in context instructional learning we've talked about it a lot, right? Is this idea of including labeled data sets and curated data sets in the training of language models, and that shows that they're better at following instructions and they perform much better at tasks that they have never seen. And this paper looks at doing that only within the prompt. So like you just get a pre-trained language model.
So like FLAN, but then only
using
and you
prompt
just engineering.
This in the prompt. And they show that like if you give it enough, like a good variety of tasks, the model sort of generalizes better to new unseen tasks. And I think this is very interesting.
So like your zero-shot performance on a new task becomes better because your prompt contains many one-shot examples of other tasks.
Exactly.
That's fascinating.
And I think that, so regardless of how much they improve performance, it's like, I think it's very interesting because there's been this trend in the last, like since ChatGPT was announced pretty much, in which people have investigated how you can play with this pre-prompt, or like kind of like the prompt that the model always sees that the user is not has access to. Yeah. And you can do so many things, right? Like a lot of this alignment stuff that OpenAI has, that most of these people have done, is just like pretty much in like describing a personality to GPT 3. And I think that this goes to kind of like show how powerful that idea of a pre-prompt is, right?
So if I take your Waluigi analogy here, if you show it enough tasks, it will say, I refuse to do any more tasks.
Could be. I don't know. There was actually this very interesting paper that didn't make it here, which was about how different model skills could do with weird sort of in context learning, and they did this thing that was very interesting on label flipping, like how well they could understand
the brother of Jason Wei.
Exactly from Google, they basically showed that larger models were more able to do that, where smaller models relied more memorizing the sort of training set.
All right, so. I don't think you're making very good on your promise to not cover only GPT, but
it was fair enough.
It was very hard, right?
If we had just been doing only the most popular stuff, I think it would have
100%.
been 100%. Yeah.
All right.
No, very quickly. This paper analyzes more the ChatGPT performance and like the whole GPT family of models in translation, which I think is very interesting, because I think anecdotally, I found that it was very good at that. And here I have an example. Yeah. And they just do that in a very broad sense. And I think most interestingly, they also do human evaluation. And I think that here you have a very nice table where you have low resource languages, and you see how GPT is not state of the art, but it's pretty good. And I think very interestingly, ChatGPT doesn't do that well on blue scores for a lot of these translations, but when you look at the human annotations, they're very much on par with the state of the art, which kind of like hints, I think, at this phenomenon that it might not, like when you look at the automatic scores for machine translation, they're not that good, but they probably qualitatively have a little bit of a different behavior. Yeah. And they sort of also like talk about how they have a little bit different type of failure modes compared to the neural machine translation trained on paired data, and I think that's very useful for like ensembling and like
I think it's an example of a whole category of papers that are coming right now, which really show how GPT has an enormous impact on all of NLP, right? Like, why would you train a specialized model for any sort of NLP task, certainly in prototyping, when the baseline
you don't care
is
so much about
the baseline is already so high.
Yeah.
So, this is
another image generation. It's a bit of a different flavor. I just found it interesting because it sort of investigates in the direction of how can you make this image generation more easier for humans to interact, or like kind of have more ways of interacting with it rather than only writing a prompt. And they just decompose images into like a whole set of human interpretable attributes, and then you can they train a diffusion model so that you can sort of play around with all of these knobs. And I think that's going to be very interesting in the space of
like a different
design
way of
exactly. It's just like
controlling
you just have more levers to pull up and down. And it's just pretty cool.
So if the Rijksmuseum in Amsterdam runs out of Vermeers, they can just generate a few more.
Something
very
like
similar, but then that's the Van Gogh phase there. I don't know.
I know. Here you just have a couple of examples of that. Of like a composition of, for instance, text, given text and depth map, and different depth maps. And here a composition of a masked image and then text. And then you can do all of permutations, all of these conditionings.
Is this from Adobe? This paper by any chance?
No, I think it was from Alibaba.
Oh, okay. Yeah, because I imagine Photoshop 2023 will be
probably
this,
right?
So we talked about language models looking things up, language models doing robotics and vision. This is kind of in some sense, the generalization of that. It's an overview paper. It's a very nice overview paper by a group from Meta with Jan LeCun and other people. They wrote also a paper called Toolformer, which I think we mentioned last time.
Yeah, we did mention.
Which is kind of retrieval augmented language models, and language model uses a calculator and a calendar.
API calls and
API calls. This is sort of kind of overview of the whole area.
I mean, I think it's a really good thing. Like if you want a snapshot of the space, that's what you get. I mean, there's not like
one thing that caught my attention in this paper is that they actually see chain of thought prompting as also a kind of tool, right? Like a reasoning tool. And,
I was also surprised by that. I mean, it's a conceptual just thing. But here I just highlighted the retrieval augmented, like the most famous ones, because that's very relevant for us.
Yeah.
But certainly I think this is going to be huge. I mean, it's already huge, right?
All these modalities and interaction modes are going to... do you want to know a nice gossip? We talked about Adapt, right? It's a startup that does this kind of action-augmented language models.
Yeah, exactly. They announced this transformer, action transformer, right?
Exactly.
September,
and it was a company founded by two of the people on the Transformers paper.
Yeah.
Vaswani and one other guy. And they already left. So they left again, the new company, to start their own company.
Start a new company?
Yeah.
Oh, wow.
Okay, so Adapt is probably...
but is there any more news about the action transformer?
No, just that they left.
Okay.
I don't know what it means.
We'll see.
So there's a lot of action in action transformers.
Okay. So I promise we would not be only talking about transformers, right? So here's my proof. So there's this symbolic discovery of optimization algorithms. I just wanted to highlight these because I don't think that this is gonna become huge or anything. But we take optimizer, like most of us take optimizers for granted, right? Like nowadays, Adam is pretty much everywhere. And this is a kind of nice paper that tries to experiment on how can you. So there were other previous papers I remember at NeurIPS, and we highlighted some I think a couple of months ago. I forgot the name, but on learned optimizers, like optimizers that use gradient descent to optimize themselves. And this is a learned optimizer that goes a different route and uses a symbolic discovery to sort of learn an optimizing function that kind of receives the weights, the gradient, and a bunch of other parameters, and tries to learn a symbolic combination of that. And they show that they speed up with Adam and all of that. I mean, the main problem with these papers is like, okay, they can, cherry pick whatever examples they have. And the only true, the thing that most people care about is actually like convenience and robustness. Like, is this a plug and play thing?
Is it
or
the
not?
paper where where the optimizer they discovered only follows the sign of the gradient?
Yes, I think so.
And forgets about the magnitude?
Yeah.
Which is actually very practical in
And
hardware
it's a good
implementation.
theoretical insight, right, as well? Or well, no, not theoretical, but like a good empirical insight. So
in Amsterdam we have to keep using Adam and defend it, but
exactly.
It's
and
the
finally,
last one.
Finally, a very fun one. It's like these guys used GPT-2, like they trained it, they encoded a bunch of Mario Bros models and worlds.
So does this count towards not talking about GPT-3 or?
I mean, ish. But yeah, anyway, this show that you can generate worlds in Mario Bros. That follow textual descriptions, and they embed these in a whole kind of evolutionary setting that kind of enables for broader like novelty optimization type of algorithm, and they just come up with a bunch of worlds. I think this is a super cool application of GPT, and like maybe it will kind of have an impact in however gaming looks in 10 years. And
I think GPT-3 can do this a zero shot in ASCII art, but
could be, yeah.
who knows?
I saw some people doing doing drawings in ASCII and stuff like that, and they were
or even SVG, right?
Yeah.
Okay.
I mean.
So let's wrap up. All of this is costing a lot of energy, and obviously energy consumption is a big thing in AI hardware accelerators. We have been promised the NVIDIA H100, which is probably about twice as power hungry as the A100, right? Most of the stuff that we're talking about runs on A100s, and I'm just still waiting for the H100. I've checked today in Zeta Alpha how many papers were published that mention the H100. It's right there. 6 for this year. So I don't think anybody has their hands on it yet in research that's writing papers, but supposedly it's available. I don't know. But there's alternatives coming up, and I think a very big initiative is being launched in South Korea, where they have actually the South Korean government is launching a tender to invest more than $500 million in AI hardware accelerators, and there's some local startups, Rebellions, and what is the other one called? Furiosa, that are making a bid for that, so they'll get a lot of funding from their own government. And both of their chips actually promise to give the same performance as an A100 at 1/5 of the energy. So that's a pretty big deal.
It's a pretty big claim. Yeah.
And if we look a little bit further into the future, I really like this paper that was posted by Peter McMahon on Twitter, and they did a kind of study on actually running transformer models, I think bird-sized transformer models on optical chips, and didn't really actually fully work. So it's not like tomorrow you can buy this.
Yeah, it does seem like it's pretty far away, but at least at the foundation, like at the principal level, it makes some sense that this type of...
It makes sense. It's like platform. In light you can do vector multiplication,
and
basically.
Also there's this whole space. I'm actually not sure if this is part of that, or like space of like analog computing type of things where like you have chips that don't operate in the...
Light is pretty analog, absolutely.
Yes, so like you can do like operations that are noisy in that space, blah, blah. I mean, it's very, it's a bit of a, probably like a longer horizon, right? At least nothing within 5 years.
In this paper, they say 5 to 10 years.
Yeah.
But they also say that on today's transformer models, like palm-sized models, you will get a energy consumption reduction of 100 times.
Wow.
And if you go to like trillion or quadrillion sized neural networks, you will have energy consumption which is 100,000 times, so 5 orders of magnitude smaller. So I mean that is pretty game. I think that's where we need to go eventually. Science fiction. All right, so let's close up. Enjoy discovery and watch out for deepfakes.
What is up with this?
All the UvA people already went home for the weekend, but this guy posted that he is a university professor in the US, Ethan Mollick, and he posted this little blog where he basically just took a snapshot of his face and asked ChatGPT to generate a lecture, which he was kind of well known, so he knew his topics and everything, and he did a university lecture and with a moving face and video and everything, and his own voice, and he did it in 6 minutes. So you really shouldn't trust any video or audio on the internet ever again. And that kind of bridges to here. So these people, I think they're from Switzerland, Schwitzgebel and Strasser, they basically made a reincarnation. Well, Daniel Dennett is still alive, but they basically fine-tuned GPT-3 on the complete works of Daniel Dennett, and then they got people to ask questions, and they had philosophy experts, and they couldn't distinguish the real Dennett from the ChatGPT from the GPT-3 Dennett. So yeah, that's pretty good. It's the path to immortality, I think. Daniel Dennett is 82. Alive and kicking, and so is Noam Chomsky.
Noam Chomsky, yeah. He's a bit older.
He is 94.
94, wow.
94, and he's still pretty sharp, I think. But yesterday he published this opinion piece in the New York Times. He got a lot of flack from,
quite a lot of flack.
From. I think Yitai said today on Twitter, "Who's this random Chomsky guy?" That's a bit unrespectful, but
but I definitely
even Christopher Manning said like, "Nah, this is."
I remember, like, I read it yesterday. It's like just like a really bad critique. Like there's many things to criticize.
I don't think he even tried it.
Exactly. Like he literally gives examples of things that wouldn't work, and then you try it, and then they actually do work.
Like John is easy to please. What does it mean? Oh, wow.
I just kind of a bit sad. It's just like this kind of like repeating talking points that has been repeating for
don't
the
do
last,
it. Don't do it. But do you like conspiracy theories?
I don't know. Depends on
I have one.
Sure.
This piece was not written by Noam Chomsky. It was written by.
It could. I feel like the arguments are really bad. So
Noam Chomsky, ChatGPT. All right. So us random guys are going to end this show. With this little fragment. It's a conversation between GPT-3 and Noam Chomsky, and it gets pretty heated. I don't understand why you keep insisting on this deep structure nonsense, GPT-3 exclaimed. It's clear that my approach worked, or else I wouldn't be able to perform so well on language tasks. And then Chomsky said, you really don't understand anything, you're just a model, and no real understanding. He doesn't know about multimodal, of course. And GPT says, you're just an old school linguist, and your theories may have been groundbreaking in the past, but they're outdated now, and it escalates. So that's it. We also have some Chomskyans here in the building still. Thanks for watching this episode of Trends in AI. The next one will be beginning of April, 6th of April.
From ECIR, right?
Either live from here, with me being at ECIR, or live from ECIR with you being here. So stay tuned.
Yeah.
Thanks.
Thanks for your attention, and see you in the next one.